Okay, so for the last couple of days we looked at exponential functions in particular places. So the first one we did was we looked at an exponential function where we had y equals a raised to the x, where a was greater than 1 and x was greater than or equal to 1. All right. Then yesterday we looked at the second condition where we had y equals ax, but a was greater than 0 but less than 1, and once again x was greater than or equal to 1. So what's another logical step that we can do to try and understand how things behave where we're doing different things and seeing different things? Well, what if a was less than 0? All right, let's take a look at that today. So again, we're going to stay with x is greater than or equal to 1. But now we're going to do a is less than 0 and see what this leads to. So let's start off and make ourselves our data table. So now we've got x and y. And let's just choose for the purposes of this, we're going to say y is equal to negative 1 raised to the x. All right? So negative 1 raised to the x. So when x is 0, any number to the 0 power is 1. It's not negative 1, it's 1. All right? When x is 1, we've got negative 1 raised to the first power is just itself. So when x is 1, y is negative 1. All right? Now when x is 2, we've got negative 1 raised to the second power. So that's negative 1 times negative 1. What do we see? That's 1. So when x is 2, y is 1. What about when x is 3? When x is 3, we're going to have negative 1 times negative 1 times negative 1. We're going to have negative 1. Wow, this is different. What about when x is 4? All right, so we've got x is 4. We're going to have negative 1 times negative 1 times negative 1 times negative 1, or 1. This thing is bebopping around going from positive to negative to negative. Let's try something a little bit different. We're going to do in between 2 and 3 for a value of x. Let's do 2.5. But rather than saying 2.5, I'm going to represent this as what? 2.5 is 5 halves. All right, so that's going to be equal to 5 over 2. All right, so now we're going to remember what we do when we have an exponent a to the 5 halves. That means that that's equal to the square root of a raised to the 5th power. All right, the square root of a raised to the 5th power. So let's look at what this means. I've got a negative number. Negative 1, the square root raised to the 5th power. Can we take the square root of a negative number? No, that's an irrational number. It doesn't make any sense. So what this tells me is that we can't plot this function because it's irrational. So this here, when a is a negative number, is not allowed. A can't be a negative number. Not allowed. So we've just plotted another point in our whole thought as to exponential functions. All right? So we looked at where for the function y equals a to the x, we looked at where a was greater than 1 and x was greater than or equal to 1. We saw that on day 1. Then we looked at a greater than 0, less than 1, and x greater than or equal to 1. And we saw that that was a function that asymptotically approached 0 as x went to higher numbers. And now we can say that a less than 0, that's a big not allowed. We can't do that. So this is one of these things that we're learning, that within this graph, we can have x's from here on over, but we can't have a's from any negative territory. And you know what? Because I'm in such a good mood having gotten through my surgery, I want you guys to get off and not have any homework today. So enjoy a day off.